Hey there, Mike Levin, October 28th, 2022, just about 8 p.m. And you might have heard me talk about Microsoft Playwright before. Microsoft Playwright they bill it as browser testing, app testing, web app testing, framework software. Now, it's really browser automation, and it's taking the place of Puppeteer, which is another one that came out not long ago. In fact, it's not long ago, it's like 3, 4, 5 years ago now, but it came out from Google as a JavaScript Node.js NPM package. And so that's what people used for, I guess, a few years to automate Chrome processes, including, application testing. Now, it must have been an important thing to Google because, to Microsoft, because Microsoft hired away two of the key contributors to the JavaScript Puppeteer project and put them to work on Microsoft Playwright, which, in addition to offering a Python client library natively, yay, has done some innovations like, what are their innovations? Asynchronous or synchronous mode support in Python. So a lot of the audience who are going to want to use Python for this is because simplification, simpler language than JavaScript to use. Although you're not going to be spared the JavaScript difficulties, because if you're going to want to do like anything even half interesting with a browser automation, you're going to be dabbling heavily into the JavaScript world, especially with CSS selectors. And I had some interesting experiences moving from Puppeteer, because I wasn't really on Puppeteer because I'm not much of a JavaScript user. I've tried it. I tried doing my browser automation natively in Puppeteer, and what I quickly learned is that I really, really, really prefer working in Python and Jupyter Notebook. Python, Jupyter Notebook, yeah, really excellent environment for feeling stuff out and seeing what works. And to do so under my current workflow is to make it work on Linux as well. Nearly identical to my real Linux server now. So I have a Linux server running 24/7 at home. I should have a long time ago. I should have many years ago. However, there's always issues about getting services running on a server, which is a way that is non-brittle over the years if it's not for hire work for an employer. So when you do it for an employer and someone's paying, you probably plug it in the cloud. So long as the client continues to pay, that application's going to keep running. But when you do it for yourself, you don't want that extra $20 or even $5 a month bill, tick, 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 whether you're using it or not. So eventually you stop paying your cloud hosting bill, the application goes away. You better hope you copied the data and have all the software in repos. But when you do it for yourself, by wanting to save that last little bit of money or to want to do it casually on and off over the years, it really works against you. Until recently. And the big change, and I've been testing this change, it was, I had a hypothesis, I had a theory. My theory was that Linux containers done well, aka not Docker, it's done well in a way for certain use cases, but for my use case, Linux containers that worked well for my use case, which was completely as if virtual machines, right? There's no isolation of apps, app isolation. That's a big part of Docker. Things can't touch each other. Things can't make changes to each other. And that immutable state, that involatile, non-volatile state, is an advantage of Docker. Original images don't go corrupt. Whenever you plug something in, it's always the same bit of code being plugged in. And anything intended to persist had to be applied in patches, composited up layers. Components working together worked in their own separate application spaces and communicate to each other through specifically opened channels of communication. While it's a nice locked down security context, it's darn difficult to just do dev work. Sometimes you just want to install this and that all on the same Linux machine and have the advantages of however tightly coupled that stuff becomes, but have the advantage of tightly coupled components to do monolithic design if you chose to, with real persistence. If you pip install, it's in there. If you apt install, it's in there. That system is changed. There is no involatile, non-volatile, there is no immutable core, because you're writing right into those locations. Although generally with, the Unix-like context, there are certain directories that rarely get written into unless you're updating the kernel or whatnot. Most app install things go into, I should learn that, different repos probably handle it slightly differently, but it certainly doesn't go into /apt. I mean, /bin, right? /bin is global for everybody. It's a set of core commands, and so on. Things get layered on with Unix and Linux that already thought of these types of things. So there's newer, better memory protected modes and isolations and rings of protection. And in fact, Windows NT sports a lot of that. Windows NT, from which all modern Windows is really derived, right? Windows 10, Windows 11, probably going all the way back to Windows 2000 Server. I guess on the consumer side, it must have been Windows 7 was NT based. Somewhere back there, they made the switch, and the thing that allows Windows subsystem for Linux to run so well these days is not anything about the Windows operating system that's exposed to the user. It's at a much lower level. One of the big complaints about pre-NT Windows was lack of security. Anything could, infect a system. So there was a large paranoia, and this came after OS 2. Microsoft had all their learnings of developing OS 2 for IBM. And so Microsoft, did a big giant flip in the bird at Microsoft, said, we're not supporting OS 2 anymore. We're all about NT. And they used everything they learned on OS 2 and applied it to NT for themselves, and had a next technology operating system that allows such neat tricks as Windows subsystem for Linux, which we're enjoying today, allowing these ziggurats of memory protected program space, system space, app space, and you got your memory protection. You got systems that can run simultaneously, multiple kernels, multiple operating systems simultaneously, and that's pretty amazing, and we're having the benefits of all that today. So these are the things I'm experimenting with at home, trying to cut down the use of as many paid-for services. I was caught in all the different traps. I was caught in, not personally, but the rack space trap. Personally, I was caught in the EC2 trap. They had me spending 50 cents a month or whatever it was until such time as I'm like, this is ridiculous. Anywho, I wrap up here, and join me again soon, and I'll be pushing this daily email thing I'm doing forward to send you some zipped up search engine results and other nifty little tricks. Thanks for joining me. See you soon. Don't forget to subscribe.